Hello, hello. We're back after a few short streams. We're now here with the epic conclusion of the last few days. But what can be more epic than having an epic guest? And this epic guest is Leon Andersen. Leon, how are you doing?
Hello. Doing pretty well. Still uh, a bit worn out, but managed to get through 1.5 sections today and yesterday together, and was fun. I didn't code along that much as the days before, but yeah, we're gonna check if I learned, if I internalized the lessons enough. Anyways, we will see. And also, what's interesting is that we're getting very close to the end of the course. So probably 2 or 3 maximum days left with the course. So the beginning of a new chapter is near. It's pretty exciting.
Very exciting, yeah.
And so let's go into what the past sections taught us. So we already talked about updater functions very shortly. I think we covered them enough. The main thing is that you have to signalize to React that it has that the updater function has to be stored basically in a temporary working memory, so it gets executed on the state. Next topic in the section on intermediate state concepts is initializer functions, which basically is just if you want to have an initial state that is more complex than just a single value or a predetermined value, you can also just insert a function as the use state. I don't think
we're not doing this in this file, right?
exactly. Yeah, I was just looking for it. It doesn't seem so. Maybe if you go to the updater JSX on the left, maybe there is something in there. No. I don't know where we have. We did that on some other examples, but as far as I remember, you then only pass in the variable name of the function, but you don't put the brackets at the end, because if you want to put the brackets at the end, then you would execute it each time the is that a function? What you wrote now is a okay. This is the don't overtake me in speed, because that's part of what I wanted to talk about as well, because basically this in line 5 is an example for not when someone does not use an updater function, and instead a single value. ChatGPT didn't didn't complain about that, so I just left it in when I checked against it. So back to initializer functions. If we put the brackets at the end, then it gets executed each time the state gets changed. And if we only use the variable name of the function, then it only gets executed once at the very first render. Did I remember that right, or?
It sounded not correct. So whether you put in there are like two things I think here that may be wrong. So the first thing is whether you put something in here as a value or whether you put the variable in is equivalent. We call that referential transparency, but which basically is a fancy way of saying it doesn't matter if we're referencing a variable or if the value of the variable is directly in here. It's the same outcome. So that means what I did earlier when you said, hey, don't be too fast, was I created a function here.
Yes, that's the updater function.
That is the state initializer function. But it doesn't matter if you put it right here where you put, and then you said you put the brackets at the end. And I didn't quite know what you mean by that, because in order to make it a function, we need to basically either write the empty brackets with an implicit return that returns the initial value. This can also take arguments, by the way. Or we would have to use the function keyword with a body and then like a return statement or something, not return. But the point basically, if like the main point of this is if there's a function in here, then the function gets executed when the component first loads and this use state is executed. And when there's just a value in here, then just there's a value is being used. So React basically behind the scenes checks, hey, is the thing that is in use state a function or a primitive? If it's a primitive, it just takes the primitive as the default value for the state. If it's a function, it executes the function to calculate the default value for the state.
Yeah, then I meant something different. So if you would go into line 4 and then make an arrow function out of score array directly, and then put in score array into a use state, and then put the brackets at the end. That's a difference, as far as I understand, between brackets and not brackets.
Okay, so what we're doing here, so brackets at the end, the technical term, because I know you like vocabulary, is we just execute the function,
yes,
or we
yes,
invoke it. So
yes.
If we define a function, then invoke it here. This is basically the same as not having a function in the first place. Because when we define it and immediately execute it, we get back this new array. You can also write this in line. You can take the invocation from here and you can take it away here and move it right here, theoretically, and that is also the same. So just in mathematics, how when you calculate fractions, the same numbers above and below the dash line, the division line, and can cancel each other out. We have the same phenomenon here, where whether we put the invocation here or here, if score array is a function, doesn't matter. And to make it a proper initializer function, you would need to put it there without the invocation here, because otherwise this is again just a hard-coded value.
Okay, if we don't have the arrow function after the score array, like now score array is not a function, right?
Yes.
Okay. Let me check real quick what he had an example with a function that console.log something and returned an array with 5,000 empty slots. And we put in, so the function was called generate game board, and he put in generate game board into the brackets of useState. Once with invoking it and once without invoking it. And when we invoke the function, it rendered each time with each render with each onClick. And if we didn't invoke it, it only rendered once at the beginning.
Yes, that is pretty much correct. I think the nuanced understanding here is that the result is the equivalent of what we have here when you have the function and you invoke it. So, because the only difference is that we would make all those wasted calculations that code was showing in that example when you invoke it immediately. Because you don't need to do that. You can just write the result in there, and the result is from that point on only managed using setscore, using the setscore function. So that would create a lot of like wasted calculations. If that makes sense.
Yeah, that's why we would not invoke it most of the time.
You probably never want to invoke it.
Yeah, probably never. So that was the that was one thing that, or the main point that.
Got it. Okay. Yeah, that was correct. But good that we untangled it.
That we don't want to do it because it gets invoked each time. Then
exactly, yes.
Yes. So and but I like you with the arrow function and then invoking it and canceling each other out. That was a different point, right? Or is that?
No, that behavior is the same as the empty pattern that code showed you, which is why I showed you, okay, hey, these two are equivalent.
So so the way it's written now, is there anything wrong with that?
No, that's completely fine.
Okay. Why would I? So making an arrow function out of a score array does not change anything.
In our case here, not, but it would be a bad use case for using an initializer function because you would only make the program more complex without needing to do it, right? Because creating a state updater function here, a state initializer function here, does not give you any benefit. So one of the use cases for adding the state initializer function is if the initial value from the use state depends on a prop, for example. So let's say for each number of player, you want to, I don't know, like the thing is, I cannot come up with a good example because let's say you want to have for each number of player, you want to have 3 slots in the array. You could just put ×3 in here, right? But there are use cases where the calculation that you needs to be done in a function, and that is when you basically want to use the updater function, the state initializer function.
Yeah, that was a good example. I like that. So because we don't need anything like that, it would be just unnecessary overcomplication to make an arrow function out of it at this point.
Exactly. Yes.
Okay, so yeah, then I already talked about, so the next topic is working with objects in state. And I mean, there's an in-between topic as well. When does React re-render? And I think we covered that before already, maybe behind the scenes in some time as well. But so basically, as soon as we have an on-click handler, yeah, clicked or executed, triggered by the click and then executed. Basically, the logic inside of the on-click handler, which in this case is the change score. I should scroll up again a bit. Basically gets everything needed for that gets stored in a temporary working memory array, one could say, and then everything gets then this gets executed on the score, and then everything renders from new, something like that, or what was the not sure what the point was of the when does React re-render, but I remember what we talked about, the updater functions, but yeah, I don't know.
Yeah, it's important to understand when React re-renders, but I do think this is one of the things where you have to burn your hand on the stove to really understand it for the first time. It's very hard to grasp if you haven't run into the cases where you're updating the state, but it's not showing in your UI, and you're like scratching your head. So because the reason is, in order for React to re-render, there needs to be a new value, which is why here we create a completely new updated score array and write that into set score. Because if it would be a reference to the old array, then React wouldn't know that the array changed, and therefore it would not re-render. And the UI would stay the same even though you interacted with it.
Okay, so that's the main part of when React re-renders, when there's a change.
There are a bunch of more nuances, but for now, this is the most important point to understand, and we're gonna go into depth around the nuances, like in, I don't know, a month or two, maybe.
Got it. Okay, so yeah, so then the point that's why I initially skipped that little section, because we already talked about that when I think yesterday explained how to work with objects or arrays in state, which is basically that, yeah, with the concept of immutability comes into play here, where React doesn't react to changes inside of an object, even if there are proper changes inside of an object, because it's still the same object with the same ID or the same identity. So we always have to create a new object or array, and we do that, as we can see here in line 8, by creating a copy, by spreading out the old state into a new. So in this case, the state is an array. We're spreading out the old array into a new array, and then update parts of it. I didn't use the Reacty way here because it was 2 or 3 lines more, but the Reacty way would be to map over the array and check if the ID or if the index matches the index that we put in, and this one we basically +1, and else gets just returned. All other elements of the array get just returned, and the map function creates a copy of an array per default anyway. So yeah, that's the how code said the React kind of way, but I don't know. I like the syntax of this one as well, so I just kept it. That was my first attempt. Did that make sense?
Sure.
Okay. So yeah, and then basically yeah, in the section we went through different kinds of ways to work with to update arrays. So adding to an array, you can just spread out, and then inside of that, so in this case, if we would want to add another another element to score, so we have an additional player, which is not useful in this example, but just to illustrate the point of adding to an array, we would just have the square brackets like in line 8 spread out with the old array, and then we would have a comma, and then we would just insert a new element there. I'm not 100% sure if that works by just putting in a number, for example, but it works. For example, if you write a new object. So if you have an array with multiple objects and you want to add another object, you could just spread out the old array, comma, and then insert the new curly brackets object inside, and then close the square bracket. Basically, creating a copy that includes the new element or object. Yeah, did I miss anything there, or?
No, was good.
Okay. Yeah, removing an element, we can do that by filtering over an array, checking if the item ID or element ID matches the one that we are or not matches, to be exact, not matches the ID that we want to delete. And if it and yeah, all the other IDs or elements of the IDs get yeah, not sure if rendered, but outputted as a new array without the one that was that we checked for. Creates a new array to filter x. What is the dash star thingy? What does that mean?
Oh, that's just an inline comment. But this was just a comment to give some visual to what you were describing.
Got it. Yeah, I think an arrow function with element dot id and then exclamation mark double equal then a number is a good example as well. Inside, so basically x.id, exactly, yeah, exactly. Even though in this case id and id is not the same, right? Like they're
You mean x.id is not the same as id?
yes.
Yeah.
Okay. So then updating all elements of an array, we would do that by mapping over the array and returning a copy with spread out yeah, basically a copy, spread out array, comma, and then we can basically add a function or whatever we want, or a method to what kind of part we want to update. So in our example, we had a shopping cart array where we spread out all the existing items into a new that's weird. Return. Not sure if I made my notes correctly, but let me check real quick. Okay. Yeah, can I send you a little code snippet?
Of course.
Because I'm confused about that. Yeah, I'll just send you the whole example then. Yeah, so now we can see the way better what I was talking about. So if you scroll down to updating all elements of an array, I'm confused there because we're spreading out the item, but we're spreading it out into curly brackets and not into square brackets, even though we are updating elements of an array and not updating a single
Yeah.
or is it because we're going object by object because of the mapping function?
Yes, exactly. Okay.
Okay.
An item is an object.
Okay, yeah. For some reason, I expected square brackets there. Yeah, that makes sense. So for each element, we spread out the inside. Oh, I mean, in this case, the element is an item of a shopping cart, and then after the comma we basically add a method onto the key of product to change all of the product names to lowercase. So this way we can update all elements of an array, or update all specific keys of all the specific values of specific keys in all arrays, in all elements of an array. Yeah. So, and I was wondering why. Also wondering. I mean, I guess the answer. I guess I know the answer, but just to double check, because a bit further up when we add it to the array, after the comma we just put in what we wanted to add at the end, and now after the comma we suddenly put a function basically, or like some more, like in line 24. We put way more. We put something very different after the comma. How does it know that we are talking about something that we're adding or something that we're like calculating, like just because of the content itself, or is there something about the syntax, like I don't know.
Got it. So these are two different use cases. So what we're saying here is our new array is the complete old array. That is what we are doing here. And we are inlining the creation of a new object that will be the new last element of the old array. So this is the same as saying this. Maybe this makes this first case more obvious. Okay.
Yeah.
Let me reverse this like this. And here, what we are saying is we take the shopping cart and we map over it, and basically each item in our previous array is modified to be whatever the old item is. This is what we're saying here. We're creating a new object here, and we're saying, hey, the old object is whatever the old item is. But then, because when we mention a key, the last mention of that key wins. So this item already has a product key, right? And there's something in there, but now we want to override it. So we say, hey, the new product key is what the current item product key is, just to lowercase. And therefore, in this syntax, every element of the existing array is changed, but the map function automatically returns a new array. So this is a new array that looks exactly like the old array, but every product in there is lowercase.
Yes. So but what if you wanted to add a new key to all of the
Products.
items?
Yeah,
Would we
then
just
you could also just create a new key. You like royalty free.
okay. Okay. Got it. So so it if there would be already a key with royalty, then it would not be added but updated.
Yeah, and updating is the pseudo term here, right? What's really happening is we're just straight up overwriting the old key.
Yes, but just logically or functionally.
Yes, exactly.
Okay. So if there would be no key of product inside of the items, what would happen then?
Well, if there was no key of product inside of the item, then this would crash. This would crash because item is defined, but item.product is undefined, and undefined.to lowercase crashes.
Got it. And if we would want to, yeah, okay, yeah. Okay, yeah, then we can go further down to modifying a particular element. Very similar to what I described earlier with deleting. I mean, in some case, because we check if the item ID is like we put the condition of having a certain ID, and then we do stuff with it. In this case, we don't. It's not about filtering it out, but to update it or to modify it, just a specific particular ID, and the rest gets returned as usual. And to sort, we have to basically spread out the old array and then use the sort method on the spread out array and not on the array itself, which should be self-explanatory why that is the case by now. After all that spreading, always be spreading. So yeah, that's that. That's all the different updating patterns that we went through. And also we went through UUID, which we didn't use in this example, but you can install UUID, which is an npm package as far as I remember, and you can then import it and then always just put or invoke a UUID function in each place where you define an ID, and then it automatically creates unique identifiers in each of these key situations. So yeah, then we can check out the scorekeeper exercise, which this is about, which is in the sandbox still, where I basically implemented a lot of it. So basically, we render a scorekeeper. Yeah, if you scroll down, you can see what we render. We return an H1 and then H3, which describes our main props, so the num player prop and the target prop that basically describe the rules of the game, and then we render the main or it's not the component because it's a mapping function inside of this component, but it's a building block. Let's say we render this building block, basically a UL, or basically a mapping function that creates allies into the UL, and also
It's an array, right? So scorekeeper list is an array of allies.
Yeah, I mean, scorekeeper list is a mapping function that creates a list of scorekeepers, but
No,
it uses
scorekeeper list is an array.
Score is the array.
I have to reload the sandbox, I think, because
Sure.
as usual, the console is dying.
Make sure to save
Reload.
before.
I think today's a no console day, probably. No code sandbox. Yeah.
The
And now not
scorekeeper
even
9000 is just too powerful for
well,
my
not even the
computer.
normal code works anymore. Um, we'll try something different.
For me, it loads perfectly.
Yeah, it loads for me again now, but the console is still dead.
Okay.
But it works in my private console. So let me pull up this right here.
Oh yeah, the console doesn't work for me. Oh yeah, no, now it works. But
Let's do it like this. Share this tab. Scorekeeper list is true, it says, right? But the console.log that we have here is array.isArray. So scorekeeper list is an array. It's not a function.
but how can the array have allies inside? And buttons?
Because li JSX is just JavaScript, so it can be inside of an array.
Okay.
Like I think code level told you that, and it's a little bit. I mean, why not? I think it's time for you to learn this truth about React. So the truth about React revealed. There's something called create element, which is a function from the React that you can use to that's basically running under the hood when you use JSX. Let me think of a good example. So you can just say const or div equals to somehow the console works here. What a wonder. Create element. And first is the type. So for example, div. And then the next thing is, I think, the children. So what if we just put hello here? Let's see if this works. I mean, we never used this. This was even before I learned how to code. This is not working, so I have to think about, the next one. So this is the second element is actually the props. So like this. Oh yeah, you see this? Hello here.
Mm-hmm.
So basically, this is create element, then a string input, no props, and the children is the same as saying this hello. And React basically behind the scenes converts this to this. And the
I
reason,
can't see the lower one because our
yeah,
router.
yeah. It converts this to this behind the scenes to this basically, and then React does its usual thing. And the reason why JSX even evolved in React was because people were tired of writing code like that. You can already see how if this is nesting, right? If you want to have a div inside of a div like here, that would look very ugly. That would look like this: create element, and then we have another div, and again empty props, and then we have the hello here, right? And you just nest and nest and nest this, and this is super hard to read. And people were like, hey, why can I not have my usual HTML syntax? And that is how JSX was born. So does that answer your question?
I don't know what my question was, but this was definitely very interesting. So yeah, I mean, my question was why it's not oh yeah, my question was why there can be LIs inside of an array.
Yes, and the reason why LIs can be in an array, because this is basically just an object, and objects can be in arrays. And this LI with all of these things, I don't know how to write this as the create element, but you can think that there's probably something going on right here. That's create element, LI, right? And then, but the thing is, the top would be the key, and then index like this. But now the children would be very complicated, because for all of these functions, we basically have to calculate what rect would do in terms of create element to do it in here. And this is a lot easier to understand and readable, which is why create element has been basically out evolutionized by the nature of code.
Got it. So but then everything is an array, isn't it?
In JavaScript, everything is an object, basically. Not an array, an object, yeah.
So like what, like, doesn't it still make sense to say that we're rendering the or that we're executing the scorekeeper lists mapping function?
That is correct, but not here, right? What the misconception that a lot of people have is that this mapping function gets executed here. But that's wrong. When the code gets to this point, it maps over this array, over the score array, and every map function returns another array. So we execute this and we get a new array, and we save the new array here in this variable scorekeeper list. And then we'll just say, hey, just render this array here.
Okay, so it gets computed as soon as we define it.
Yes.
And then later it only gets rendered.
Yes. And you could obviously move this computation down into the rendering code if you do it like this.
Yeah.
But that is again just the referential equality that we talked about earlier.
Yes. Okay. Yeah. Well, we're rendering the results of the score of the mapping function. And the mapping function includes or takes in the arguments of the player score and the index, and of each element of the array. I mean, player score is basically the value of each element, and it creates an LI with the key of the index of its index of the element of the array, and for each inside of each LI we have I wrote it down, and I split it up into components in a bit. I would say not sure if it's overcomplicated, but I split it up. So we have each each are all of these arrays now inside of inside of LIs? Like is player LI an array? And score button is all of that an array?
No, player li is a function, and when we invoke it here, it becomes a string, right? Because it returns a string.
Okay. Could we call each of these, like from line 22 to 25, elements, or like, because like elements is reserved for array elements, but like I don't know how to describe what is inside of the li, like what the best vocabulary is there.
Well, it is a little complicated because there are multiple ways to describe it, which are all true. So by the technical definition, all of these functions here are also React components. Usually you uppercase the React component like this by definition, but you don't have to. But in terms of how React basically thinks about this is just a function that returns a string. But a string is a subset of JSX that is valid, right? So if we put in here just the string hello, React knows what to do with it. If we put in true as a boolean, React knows what to do with it. If we put in a number, React knows what to do with it. So the point is that returning any primitive that React knows how to deal with, or JSX, which means other components or native components like li, so that's all valid JSX. So every function that returns JSX is a React component. So in a way you could say, hey, you have just 4 React components here that instead of using them like, let's comment about, instead of using it like this, player li, and then we say score equals to, oh no, we have to, yeah, because of the function, we can, these are the props, right? So we cannot put in the second ID. So we cannot change this one, but we could change this one to a React component like this. And we could say, oh no, we cannot even do it here, right? Because it takes all of the props and there's no way to say, hey, all of the props are just one number. So it's just, it's impossible to refactor to a React component. Yeah, so and then the other way to describe it, so technically speaking, these are all React components. The other way to describe it is if you say we're evaluating expressions here, right? Which the curly brackets do. So we're going into within JSX JavaScript expression evaluation mode, and then we are just executing a bunch of functions.
Okay, yeah. So why are those functions and scorekeeper list isn't a function? Because scorekeeper
If you
list
want to make
gets,
scorekeeper list a function, you would have to do this.
okay.
Now it no longer works. If we save this, that's right, because we're not invoking it here. Well, React doesn't know what to do with the function if it renders it, so it just screams at us that functions are not valid as React children right here, and that doesn't work. So arrays are valid React children. That's why this works. And the reason why these are functions and this is an array is because map is immediately executed, right? Here you're defining a bunch of functions and you're executing them here. But the map function is immediately executed as soon as JavaScript comes across it.
Okay, but map is a function, right?
Map is a function, yes.
Okay. Yeah, it's interesting why, like, if map is a function, why is scorekeeper list not a function as well? I don't get it, but
Okay, I can show it to you. So let's say we have our little thing here. We say, hey, const my array equals to 1, 2, 3, 4, right?
okay.
This is an array. Can we agree?
Mm-hmm.
Cool. Okay. So let's say we say my array dot map x times 2. Is this a function?
Mm-hmm.
This is an array.
Well, it's a function used on an array.
We use an array method, right? And we put a function into the innocent argument because that's what map expects. But if I capture this, what is the result?
Yeah.
Result is an array.
Yeah.
And here's our result. And you don't do this. You don't say, hey, this will blow up because it says, hey, we cannot invoke an array. Result is not a function. We cannot invoke it.
Okay.
And I think it's just a little bit confusing maybe seeing this inside of React. What is exactly the same that's happening here? We just define a new variable where we save the result of map. Because I think this you have seen many times by now, but this was the first time that you've seen it inside of a React component.
Yeah. Okay. So the variable relates more to score than to map.
Yeah, because score.map is map is a method on score, but if we call this method, it's immediately executed.
So a few moments ago, you said map is a function, not a method.
The technical term, like all methods are functions, but not all functions are methods, right? So both is correct.
Okay. Okay. So if map
Yeah, let me have I have no idea to visualize this to you. So if we want to make scorekeeper list a function, we would do this. Right? Because map is a function. So, or technically speaking, map has a method on an array, and since score is an array, map is a method on the score array. But now scorekeeper list is a function, and we are just executing it immediately, right? And as soon as you execute a function immediately, you get the result. But the argument that it takes is
okay,
the
because
callback
it's
function.
executed. Because it's
Yes.
executed.
Yes.
Okay. Got it. Yeah, okay. So the functions above, like player li, score button, winner label, all of them, they are functions because they aren't executed right away.
Exactly.
Got it. Okay. That's a great nuance. Okay, cool. So yeah, basically each li gets the results of 4 functions. The player li function, which is the player ID and the player score. Then the score button, which takes in the index as an argument. The winner label, which takes in the player score and the target, and the reset function, which also takes in player score and target. And yeah, I could have written all of those of the all of the logic of these functions directly inside of the li, but I wanted to yeah, just try it out how it is to refactor it this way. What would you say is better practice, to write directly inside of the inline, or like in this case?
Yeah, for these simple things, you usually do it just inline.
Okay.
Well, the more advanced answer is usually you would do this stuff, for example, in your state management, like in Redux, or you would format it directly on the server in a way that you don't need to do many calculations on the front end.
I have no idea what Redux is.
You don't need to. We'll get to that.
Okay. All right. So yeah, but in the end, I still had less lines than code. So I don't know. But I would say it's like, to some degree, it's a bit more like it's a better overview, but on another level, it's a worse overview. This way, I don't know. But I did it this way, and yeah, that's what we got. And the most important part of all of this is basically just the updater, the change score function. That's a function, right?
Yes.
Yes, finally. So yeah, to basically implement the unique array concept for updating the use state, or getting React to re-render. Yeah, it's a very long talk about this. This app, but yeah, it actually took quite a while for me to get all these components, or yeah, these building blocks together. Yeah, I guess it was a good exercise, and I guess we can go to the next section, which is component design. And here you can open the code from that. So basically, the section began with how to think, like how the thinking process has to be, like how to decide in which level of all these parent and child components we can put the logic. So we have dumb components, or representational components that just take in values and represent them, and then we have components that actually have the logic inside. And the rule of thumb is to always lift the logic as high as possible, but not as high as possible, but as high as needed, but not higher. And the thing is that we can't we can only bring not sure what it was, like migrate from above to to below, or the other way around. There was something, how's it called? We can't pass upwards, but I don't remember what we can't pass upwards, because we can definitely. Oh, we can't pass downwards. Oh man, I forgot now.
So you cannot pass upwards, right? You can only pass props downwards.
Okay, props. That was okay, but yeah, that okay. Yeah, then that was it. Yeah, passing props downwards only works. So this way, because of that, we have to be conscious about how we structure, how the components relate to each other, and what is inside of what component. And yeah, in this example, also because we want our goal with the lucky n component was that we make it as reusable and variable or flexible as possible. So we can not only use it with one set of dice or one set of target value of the dice, and so yeah, basically, if we go to the lucky n JSX, we see that we yeah, what are the most important parts? Yeah, we do the check if the is winner how did we win check of dice? Where's win check? Why is this in the app.js? That's weird. What? I don't remember that this was in the app.js. Isn't that a component too high?
Not if you want to put it as props, right? Apparently he wants to or you guys or Code wants to reuse the lucky n component, and in order to do that, you need to take in the win check as props, and therefore you can have two lucky n components with different win checks, and therefore these win checks need to be defined here, right? Because if you would define them in the lucky n component, then they would all share the same win check, which is not what you want, because you want to change the win check.
That makes sense, yeah. So okay, so basically the win check takes in a function as a prop, which has its own logic to check if the dice that are being rolled are checking the requirements, and the dice are being rolled in cons roll, and are being yeah, if we click the reroll button, as we can see, the roll function gets executed. So this updates the state of the dice. The get rolls was an import from a utils, a different JavaScript file. I think we took that, which is basically a math.random what is a math.random which is tailored to a length of the array, and has in this case six sides on the dice. And yeah, if you go back to lucky n, we can see that we have all the logic, most of the logic we have inside of here. Only the functions that are the props have to be a level higher. And if we go to the die component, we see that it's only taking in a value which it receives from the dice component, which is one level higher. And this dice component gets the value also from the dice value which it got from the level above from lucky n. In line 14 we can see that it's passed in as a prop, and we get that from where is it? Yeah, that's basically the state that we created by clicking roll, and also by the initializer. This is a good example of an initializer or initializer function. Get rolls with num dice inside is basically
No, it's not.
no?
Well, because that rolls is being executed here, right? Initializer function means there has to be a function inside here that is not executed. The example here is basically the exact example that code shows, where this gets executed on each render. So if you put a console log into get rolls, then it gets executed on each render, even though only the first execution is used to initialize the default state.
That's weird. So basically, is there any difference between couldn't we just use the or ignore the roll function then completely if it gets executed each render anyway?
So you wanna if you want to fix this, you would do it like this. Because now it's a function and now it only gets executed once.
So before that, did it override the roll function?
No. Only the first result is being used, right? But if this was some expensive calculation, it would slow down the computer of your user because it would be executed on each render, but only the very first result is being used. So the same problem that basically Cole showed you earlier, which we talked about at the beginning of the stream, is happening here because it's not a function, is a result.
So this gets executed after the roll function?
Yeah, no, it gets like the component loads, this gets executed. Everything here gets rendered. The user clicks roll updates the state. The component re-renders, this gets executed again, but the result is ignored because only when the use state is initialized does it use whatever is in these brackets here. So the second render happens, this gets ignored, and with the second render, we are rendering the new dice state that was set in the previous invocation of the roll function.
So use state ignores it, but it still gets executed anyway, and
yes,
computation just happens.
Yes.
Okay. At least that. So so then we uncovered a mistake of code, even though it's not that big of a computational loss in this case, but it would make sense to still write it as a function, right? Or
yes, exactly.
Okay, so but it still doesn't change the structure of the logic that I described, right? From die to dice to lucky n.
Yes, exactly.
So that's the main point, like how all these how the logic is structured. That's the main point of this section basically, and Also, yeah, passing functions as a prop, which we had with the win check example right a few moments ago. That's basically yeah, very important concept, and and that's it for this section. And then we have the React forms, which is yeah, we have a special behavior there where it's if we don't like, if you go to form demo, I guess. Yeah, I think that this explains it good. Handle registration, handle error. No, this is wrong one. Then shopping list should work as well. If we want to write something into a form, we can see the inputs. Where are the inputs? Maybe if you scroll down, are there any inputs? Forms? No. I didn't see that file. So yeah, here we have the inputs. This is the file that I was looking for the explanation. If we want to write anything into the inputs, we have to connect it to a few React features, basically, in order to write anything into because otherwise how do I describe it? Everything that gets written into an input is a React state, and we have to set a few things up so it works fluently and doesn't block or and so it passes the right values to the right place, basically. We start, I would say, by setting up the forms. If you scroll down to the forms, the inputs, we have a product name and another form below. If you go further down, the quantity. We have to in React basically there are so many different things. We have to link the label to the input with HTML4, because for is in JavaScript is reserved for loops, for loops. So it's just similar how we use class name instead of class in JSX. We have to use HTML4 in this case, and then we have to. I think the most important part, except for getting all linking everything with the name and ID, is that we set up the on change, which basically listens for any kind of change inside of the input, and this has to then go into the handle change function, which basically why is there validate? Oh, he built in some validation stuff already. I think I think we can ignore the if statement there for now. And we can just go to the set form data in line 18. We can look at that, which is basically that the handle change function is basically the on-click handler that we usually have, but it's not an on-click handler, but it's an on-change handler, and this directly updates the state via the set form data, which is our set state equivalent. In this case, it takes in the current data and returns a copy of the current data with the event.target.name, which is the one could say the destination of the input, where the input is coming from, and from there it gets the event target.value, so the value that's inside of that gets written into the input, and writes it into this copy of the current data. So it's basically with each change we create a new array with the new values inside. Did I explain that correctly?
Yes, except it's not an array, it's an object, right?
Got it. Yeah, of course. Yeah, it's a key value pair. Yeah, this is the basic concept, and one could basically do that for each individual input, but we can just use a handle change function to handle all of the inputs and basically update an array where all of the inputs are, like one object where all of the different input data is stored, and instead of separate arrays or separate objects that get updated with individual change handler functions, and yeah, what we see here as well, the square brackets in line should be 21. The square brackets around that is called computed property name. So basically, this computes out of the event.target.name. It creates the key that we're looking for. So we can write the value inside of the right key. Would this work without the square brackets?
No.
What would be different then?
So what we're basically having here, let's create this example real quick. So this is the line, right? So we have an event here, event with a target and a name and a value, right? And the name is this right here, it's product, and the value is this right here. And when we say this part of the line, so const name, so this is basically the abbreviation of it. Name value. Const say this. And if we don't put the square brackets here, right, and we say it like this again, event.target.name, and we don't put the square brackets here, this is not a valid key, right? It complains about the dots, and then if you, let's say, put in quotation marks here, now the key name is event.target.name. Right? So in order to basically evaluate it in JavaScript, similar to what the curly brackets do in JSX, you need
Yes.
the square brackets. That's why why the name is literally computed key, right? Because the key is computed.
But why don't we need that for value?
Because that's how value always works, right? Value can always be a variable. So you don't need it for value, because whenever we create an object like this side can be an expression.
Got it. Yeah, because the key is always a string, we have to make sure that it gets computed before it gets turned into a string. Would that be a description?
Yes, keys always need to be string, and also the opposite, right? If we put square brackets here, now this is an array.
Yeah, makes sense.
Value, right? Yeah.
Makes sense. Yeah. So that's computed property names, and yeah, that's the basic. The basics out of this. The rest of this section is form validation, and I will finish that tomorrow, and that will be part of tomorrow's stream.
Great. Any last thoughts, epiphanies, things you want to share?
No, I think going through my questions should be it.
Nice. Then we are done here. Thank you everyone for watching this. As we announced a couple days ago, we made another director's cut stream, another 1.5 hours. We hope you enjoy. If you're watching us live, please join us again. Leave your questions in the comments if you have any. If you're watching the recording, why don't you join us live? It's always fun and you can learn something. And as you see, we progress. So at some point, we should be covering something that is right at your skill level, right? And if this is already too far for you, then just go back a bunch of streams and see where you are in your journey and pick up from there. And get also absorb all those nuances into your brain too, because it will enhance your programming skills a lot. So thank you everyone for watching. This has been day 78 of 100 Days of Code with
Leon Andersen and my mentor.
I have no. So what did you say today? Always be
copying arrays.
Spreading. Always be spreading and always
be spreading. Exactly.
Bye.
Bye bye. Until tomorrow.